In this video, we'll do examples of finding a confidence interval for a mean based on a sample. And this is when the population standard deviation is unknown. So we'll find a confidence interval, and that looks like the sample mean, the mean from the sample, minus a margin of error to the sample mean plus a margin of error. And that confidence interval is to estimate mu, the true population mean. And so the sample mean x bar, we know what that is. The margin of error is given by t from the t distribution times s, the standard deviation for the sample, divided by the square root of n, the sample size. So x bar, sample mean, lowercase s, sample standard deviation, and n is the sample size. We also need to find t, and to find t we use a t distribution table, and the two pieces of information we need to read that table are the degrees of freedom. This is just the sample size minus 1, and the area in one tail, and that's based on the confidence level. So we'll be on a 90% or a 95% or a 95% confidence level looking for a confidence interval of that type. And the area in one tail is 1 minus the confidence level over 2. So like for example, 1 minus 0.90 over 2, that is 0.1 over 2, that's 0.05. That is the area in one tail of the distribution, because if we have 90% in the middle, then we have half of the rest, half of 0.01, 0.05 in each side. So here is an example. We want to estimate the average lifespan of a certain brand of laptop computer. In a random sample of 40 of these laptops, the mean was 6.8 years and the standard deviation of the sample was 1.6 years. Construct a 95% confidence interval for the average lifespan of these laptops. Okay, so let's think about what we know so far. We know that the sample mean is 6.8 years. We know that the sample standard deviation is 1.6. We know that the sample size is 40, and we're looking for a 95% confidence interval. Okay, so we know that this confidence interval is going to be of the form sample mean minus the margin of error to the sample mean plus the margin of error, where the margin of error is equal to t times the sample standard deviation divided by the square root of the sample size. So we know each of those pieces except for t. We still need to find t, and finding t is based on two pieces of information, the degrees of freedom, and that's the sample size minus 1. So in our case, that's 40 minus 1, that's 39 is the degrees of freedom, and it's also based on the confidence level. So since this is a 95% confidence interval, that means we've got 95%, 0.95 of the data in the middle, and so we'll have 1 minus 0.95, 0.05 in the tails together. So the amount in just one tail is that divided by 2. That's 0.025 in each tail. So that is the column we're interested in. We're interested in the column 0.025, and we're interested in 39 degrees of freedom. So in other words, the sample size minus 1 is 39, so we're interested in that row. So the place where this row and this column meet up is at t equals 2.023. So t is equal to 2.023. And now we have our margin of error E is equal to t times the standard deviation for the sample over the square root of the sample size. So that's 2.023 times the standard deviation for our sample was 1.6 divided by the square root of the sample size. The sample size was 40. And so when we multiply those two values together, we'll get a margin of error of 0.512. So that's our margin of error E. And now we can find the confidence interval, the sample mean minus the margin of error to the sample mean plus the margin of error. And so that gives us, our sample mean was 6.8 minus 0.512 to 6.8 plus 0.512. And so our confidence interval is 6.288 to 7.312. So that is our confidence interval for this mean. And again, what that's saying is that if we took if we took the sample mean many times for different samples of size 40, then 95% of them would fall within this interval from 6.288 to 7.312. So in that sense, we have this confidence level of 95% that the true sample mean of the lifespan of these laptop computers is between about 6.3 years and 7.3 years. Here's another example to try. We want to estimate the average height of Douglas fir trees in a particular region. A random sample of 85 of these trees has a mean of 32 feet and a standard deviation of 4.3 feet. Construct a 99% confidence interval for the mean height of these trees in this region. So I'd encourage you to pause and try this out. All right, let's first start by writing all the things we know. We know that the sample mean for this sample of 85 trees was 32 feet. We know that the standard deviation for this sample was 4.3 feet. We're going to be finding a confidence interval, the sample mean minus the margin of error to the sample mean plus the margin of error, where the margin of error is equal to t times the standard deviation of the sample over the square root of the sample size. The sample size was n equals 85 trees. That's our sample. Okay, so we know S, we know N, we need to find T. T is from the T distribution, and it's based on two things. So T is based on the degrees of freedom, and that was 85 minus 1, that's 84, the sample size minus 1, and also on the confidence level of 99%. So here we've got 99% in the middle. We want to figure out how much is in a single tail. So in the two tails together, it's 1 minus 0.99 is 0.01. In a single tail, it's that divided by 2, so 0.005 is the area in one tail. And so that means that we're going to be looking at 0.005. We're going to be looking at this column. So which row should we look at? Here's an issue. There is no 84 for degrees of freedom. There's 80 and there's 90 and there's nothing in between in this table. So one option is to always do sort of the more conservative estimate, and if the value that you need, the degrees of freedom that you need is not there, to use the lower estimate because it's more conservative. Another option is to go in the middle and take the average of these two. Either way is fine, and it won't make a very big difference once you get up to that far up in the table where not all the values are included. These differences are pretty small. So we're going to use t equals 2.639. We're using the value from 80 degrees of freedom. But again, we could have taken the average between 80 and 90, and it won't make a big difference in any of the problems that you're doing. So t is 2.639, and now that means that our margin of error is t times standard deviation for the sample over the square root of the sample size. That's 2.639 times our standard deviation was 4.3 divided by the square root of the sample size. That was 85. And so when we multiply that out, we will get 1.23 for our margin of error. So 1.23, this is also in feet, is our margin of error. And so that means that our confidence interval is the sample mean minus the margin of error to the sample mean plus the margin of error. So that's our sample mean was 32 feet minus 1.23 feet to 32 feet plus 1.23 feet. And so our confidence interval then is 30.77 up to 33.23. And that is our confidence interval for the population mean. Based on this, we would say that we have a level of 99% confidence that the true population mean, the average height of this type of tree, is in between the interval 30.77 to 33.23, or in other words, we've got a sample mean of 32 with a margin of error of 1.23 feet.